The conversation begins by referencing a cosmological model that closely aligns with the idea of the Big Bang. While the Big Bang is mentioned, it is emphasized that this event did not represent the initial point of the universe's existence. Rather, many factors about the universe have been revealed, such as stellar systems, dark matter, and dark energy. Research and observations have played a pivotal role in enhancing our comprehension of the universe's formation and its ongoing expansion. Recently, however, the James Webb Space Telescope, JWST, has uncovered a surprising discovery that may challenge the widely accepted model explaining the universe's evolution, even questioning some fundamental laws of physics. What exactly was discovered, and why does it have such profound implications? In this video, we will delve into the implications this discovery has on our understanding of cosmology and its significance for the scientific community. The image captured by the James Webb Space Telescope has radically transformed our understanding of the cosmos, shattering long-established views of the universe's evolution. Gaining insight into the vastness of the universe has always been of great importance to humankind. Our curiosity about the origins of the vast world around us has fostered the development of disciplines like astronomy and cosmology. Through these fields, we have gathered extensive knowledge about space and the remarkable phenomena within it, including evidence that the universe does not exhibit a homogeneous distribution. Certain regions of space demonstrate higher densities than others, a phenomenon that supports the Big Bang Theory. The Big Bang Theory. The Big Bang Theory is the prevailing scientific explanation for the universe's origin, proposing that the universe began as a singular, massive explosion, followed by its expansion and subsequent cooling. Several phenomena support this theory, including the cosmic microwave background radiation, CMB, which emerged after the universe's first moments and is often regarded as an echo of the Big Bang. The CMB has been around for over 13.8 billion years and holds valuable clues about the early universe. Over the years, theories explaining the universe's evolution have undergone significant changes, driven by new discoveries and advancements in research technology. These findings have prompted necessary adjustments to existing theories and, at times, the creation of new ones. The primary goal of the James Webb Space Telescope has been to provide sharp images of space far beyond our planet, as well as to explore the most distant regions of the cosmos in search of stars and galaxies that formed soon after the Big Bang. By studying these celestial bodies, scientists can gain a deeper understanding of the processes that lead to the formation of stars and planets, as well as gather insights that might either refine or expand the Big Bang Theory. Technological advancements have enabled researchers to introduce concepts like dark matter, dark energy, and the continued expansion of the universe, all of which align with the Big Bang Theory. For instance, the theory of universal expansion suggests that the universe is perpetually expanding, with galaxies and galactic clusters moving farther apart. This process is believed to have been ongoing since the universe's inception around 13 billion years ago. Scientists propose that dark energy is the mysterious force responsible for this expansion, while dark matter, though invisible, plays a crucial role as well. Over the years, various methods have been developed to detect or measure dark matter in the universe. The James Webb Space Telescope has proven invaluable in this regard, providing high-resolution images that allow astronomers to estimate the amount of dark matter in specific areas of space. In addition to these efforts, general relativity, which explains how massive objects warp space, also contributes to our understanding of dark matter in the universe. The discovery and its implications. Recently, the James Webb Space Telescope has made several extraordinary discoveries, one of which involves detecting objects resembling planets within the Orion Nebula, a well-known region of space in our galaxy. Earlier studies had not identified such objects in this cosmic cloud of gas and dust until the James Webb Telescope made this discovery possible. These findings are only a glimpse of the numerous remarkable revelations the James Webb Space Telescope has recently brought to light. However, one discovery stands out as particularly troubling. The impact of this finding has significantly challenged our conventional understanding of cosmology, as it suggests a scenario that may call into question the validity of the Big Bang Theory. What exactly did the James Webb Space Telescope uncover, and why has this discovery caused such a shock to the foundational principles of cosmology and astronomy? The James Webb Space Telescope has recorded the disappearance of over 771 trillion solar systems, an event that appears to defy a fundamental law of physics, the conservation of matter. According to the law of conservation of mass cannot be created or destroyed, but it can change from one form to another. Since research on the universe has always relied on such principles, scientists now face the challenge of explaining the sudden disappearance of entire solar systems composed of stars and planets. Were these systems destroyed, or did they simply change in some way? Some experts have proposed a plausible theory suggesting that the disappearance of these solar systems could be due to a transformation of their mass. In this scenario, the stars and planets may continue to exist in the cosmos in forms that we currently cannot detect. This theory is supported by events that occur when stars age and can no longer hold on to their gases, resulting in explosions known as supernovae. During these explosions, stars release their mass into the universe as tiny particles. Some scientists speculate that something similar might have happened to the solar systems that vanished without a trace. Despite this possibility, the majority of the scientific community is skeptical of this explanation, as stars do not typically disappear without leaving any evidence, especially without undergoing a supernova. Furthermore, the massive disappearance of these trillions of stars should have left a significant impact on the universe, including our own Milky Way galaxy. Another theory suggests that black holes might be responsible for the sudden disappearance of these stellar systems. Black holes are regions of space with extremely high gravitational forces that absorb matter, including light. In some cases, they can even consume entire stars. However, the idea that black holes are behind the disappearance of trillions of stars seems unlikely. It would require an enormous number of black holes to account for such a vast number of missing stars, which does not seem consistent with what we know about these astronomical phenomena. The uncertainty surrounding this event has prompted a group of scientists to dive into historical research in search of potential explanations. Final thoughts and future discoveries. The discoveries from the James Webb Space Telescope are pushing the boundaries of our understanding even further. The ability to observe the universe in unprecedented detail offers opportunities to answer questions that have puzzled scientists for generations. These findings could have far-reaching implications for the fields of several critical questions that challenge both our current cosmological models and our fundamental understanding of physical laws. If this disappearance isn't a fluke or misinterpretation, we must consider the possibility that our understanding of the universe's structure and behavior is incomplete. Could it be that the laws governing matter and energy are more flexible than we thought? Or is there an entirely new force or phenomenon at work that we have yet to fully grasp? As we move forward with these exciting discoveries, one thing is clear. We are on the cusp of a scientific revolution that will reshape our understanding of the cosmos in ways we are only beginning to imagine. The universe is waiting to be explored, and together, we can uncover its most profound mysteries. A new era of cosmic exploration. As scientists continue analyzing the data from the James Webb Space Telescope, JWST, the mystery of the disappearing solar systems grows deeper. Theories are being tested, calculations refined, and yet, no definitive explanation has emerged. The implications of this anomaly extend beyond just astronomy. They challenge the very foundation of physics itself. Could it be that the laws of physics, as we understand them, are incomplete? As researchers sift through the JWST's high-resolution images, a new pattern begins to emerge. Some regions of space that were once thought to be empty now appear to contain faint, almost imperceptible distortions, as if something massive is present but hidden from direct observation. This has led some scientists to propose an even more radical hypothesis, a new form of matter or energy beyond anything we've ever encountered. A breakthrough in understanding. One possibility gaining traction is the existence of phantom matter, a theoretical substance that does not interact with light, conventional gravity, or any known forces in the standard model of physics. If such a phenomenon exists, it could explain why entire solar systems seem to have vanished without a trace. Instead of being destroyed, could these systems have shifted into a different state of existence, one we cannot yet perceive? To test this idea, scientists have begun conducting experiments on Earth that push the boundaries of physics. New particle accelerators are being proposed to simulate extreme cosmic conditions, hoping to uncover traces of this mysterious matter. Meanwhile, the largest radio telescopes on the planet are being aimed at the affected regions of space, scanning for any unusual energy signatures that might hint at what truly happened. But then, another unexpected discovery shakes the scientific community. A signal from the void. As researchers analyze deep space radio data from the JWST, they detect a strange, repeating signal originating from one of the regions where the solar systems vanished. The pattern of the signal is unlike any known natural phenomenon. It is structured, rhythmic, and mathematically precise. At first, skepticism reigns. Could it be a glitch? An undiscovered type of pulsar? But as the data pours in, a chilling realization sets in. This may not be a natural occurrence at all. The frequency shifts in the signal follow a sequence so precise that some scientists begin to entertain a once unthinkable possibility: an artificial origin. Could an advanced civilization be responsible for what we're observing? If so, what could they be doing that causes entire solar systems to seemingly vanish from existence? The next step. With this discovery, an emergency meeting is held at the International Space Research Council. Some argue for caution, warning that any attempts to communicate could be dangerous. Others believe this could be humanity's greatest opportunity to finally make contact with an advanced extraterrestrial intelligence. Meanwhile, deep in the observatories of NASA and the European Space Agency, a new mission is being planned. A fleet of next-generation space probes, equipped with revolutionary quantum sensors, is set to be launched toward the affected regions of space. Their mission: to get closer than ever before and uncover the truth behind the missing solar systems. As the countdown begins, one thing is certain: we are on the verge of the greatest discovery in human history. Into the unknown. As the world watches in anticipation, the Deep Space Quantum Reconnaissance Mission, DSQRM, is launched. The fleet consists of 5 autonomous probes, each equipped with cutting-edge quantum sensors, AI-driven analysis systems, and advanced propulsion technology. Their destination: the void where the 771 trillion solar systems vanished. On board the lead probe, Horizon 1, an AI system named Athena continuously scans the deep space signal, searching for patterns, deciphering its meaning. The further the probes travel, the stronger the signal becomes, as if something or someone is acknowledging their approach. Then, suddenly, one of the probes disappears. No explosion. No trace. Just gone. The edge of reality. Panic sets in at mission control. The remaining 4 probes attempt evasive maneuvers, but another vanishes seconds later. Scientists scramble for explanations, but none make sense. There's no sign of energy disturbance, gravitational anomalies, or time dilation. Athena, now running millions of calculations per second, begins analyzing the last transmissions of the missing probes. After an agonizing wait, it detects a bizarre phenomenon. Space itself seems to be folding. Not like a wormhole or a black hole, this is something entirely different. It's as if the very fabric of reality is being rewritten in real time. The disappearing probes weren't destroyed, they were removed. From where? Or by what? The revelation. As the remaining probes cautiously advance, they finally reach a point where the distortions converge, a region where light bends unnaturally, time flows inconsistently, and space itself seems different. The quantum sensors register something impossible. A structure. Not a planet. Not a black hole. Not even a Dyson sphere. Something beyond human comprehension. Athena struggles to describe it: an immense cosmic lattice made of pure energy and shifting matter, extending beyond measurable space. It doesn't just exist in space, it seems to exist outside of conventional reality. And then, for the first time, the signal changes. Instead of a repeating pattern, a new transmission arrives. It's not random. It's language. A single message, deciphered by Athena. You were not meant to see this. What lies beyond? As soon as the message is received, the final 3 probes begin shutting down. One by one, their signals fade as if some external force is disconnecting them from reality itself. Back on Earth, Mission Control watches in horror. The last probe, Horizon 1, barely manages to send one final image before its transmission is cut. A silhouette. Vast. Unfathomable. Watching. And then, silence. A choice to make. With no remaining probes and no way to understand what has happened, the scientific community is left facing a terrifying question. Were these solar systems erased from existence? Or were they taken? And if so, by whom? The message left behind suggests an intelligence beyond anything humanity has ever encountered. But the warning is clear. We were not meant to see this. Now, world governments must decide: do we continue searching? Or do we turn away, pretending we never found anything at all? Because if we keep looking, we may find something we were never supposed to find. And worse, it may find us first.